Let's see the formulae of the three important trigonometry functions. We consider the same triangle we have seen before. This is the side adjacent to theta, this is the side opposite to theta, and this is our hypotenuse. We have seen the formula of a sine function. Sine theta equals opposite divided by the hypotenuse. Remember, we don't write an e here. Then what is the cosine function equal to? The cosine of theta is written as cos of theta. We ignore the ine. The cosine of theta equals the ratio of the length of the adjacent side, which is this side, to the length of the hypotenuse. Cos theta is adjacent by hypotenuse. The third important function is the tangent function. As I said before, the names sound very fancy, but the formulae are very simple. The tangent of theta is written as tan theta, and that equals the ratio of the length of the side opposite to theta, which is this side, to the length of the side adjacent to theta, which is this side. But the word tangent sounds familiar. Isn't it a line which meets the circle at just one point? Yes, that's correct. But we don't see a line or a circle anywhere in the picture. Don't worry about it now. You will know why it's tangent in one of our other videos. So let us review what we just did. Sine theta is opposite by hypotenuse. Cos theta is adjacent by hypotenuse. And tan theta is opposite by adjacent. Let's play with these formulae. Let's try dividing sine theta by cos theta. Sine theta is opposite by hypotenuse. Sine theta by cos theta also equals sine theta multiplied by 1 by cos theta. 1 by cos theta is actually the reciprocal of cos theta. And the reciprocal of cos theta would be hypotenuse by adjacent. So we multiply this by hypotenuse by adjacent. Look at the right hand side. Can we reduce it further? Yes, we can cancel out hypotenuse from the numerator and the denominator. That gives us opposite by adjacent. Hang on, does this look familiar? Of course it does. It's the value of tan theta. We just proved one of the most important relations in trigonometry. Sine theta by cos theta equals tan theta. But how do we remember so many formulae? It's very simple. Observe the first letters in each of the cases. Look at the first formula. S, O and H. So let's write SOH here. Now look at the second formula. It's C, A and H. So we write CAH here next to SOH. And in the third formula, it's T, O and A. We write TOA here. What we get is so katwa. Well, it may sound funny, but that's the best way to remember the formulae. So katwa. So let's review the formulae one last time in this video. Assume we have a right triangle with lengths 3, 4 and 5 units. Before we find the values of sine, cos and tan, let's write our code on top. So katwa. Now see how simple it gets. Let's find sine theta first. It's so sine is equal to opposite by hypotenuse. The side opposite to theta is 3 units long and the hypotenuse is 5 units long. So sine theta will equal 3 by 5. Now let's try to find cos theta. See the code it says Ka. A and H stand for adjacent and hypotenuse. So cos theta is adjacent by hypotenuse. The side adjacent to theta is 4 units long and the hypotenuse is 5 units long. So cos theta equals 4 by 5, which is 0.8 approximately. And what about tan theta? It equals opposite by adjacent. Opposite side is 3 units long and adjacent side is 4 units long. Tan theta will equal 3 by 4. This video was purely formula based. To really understand how the functions vary with angles, do watch our video based on unit circle.